with our morning session. You were given a question yesterday, that's question number 11. So we are now going to look at the correction of question 11, right? So may I refer you to your WhatsApp? It's question 11. I'm not sure about the date it was posted, but I'm assuming that you all have it. Please, if you do not have, just ask the person next to you to share with you. Now, the question is based on electric circuit. There is a circuit that is drawn on your picture if you look at your cell phone. And we're going to start with the first question. So the first question says, define the term potential difference, right? So that's question 11, and that's 11, that's 11,1. So let's answer that. What do you think that is? Asiki?
The energy transferred per coulomb of a charge.
Asiki?
The energy transferred per coulomb of a charge.
C. Transferred per coulomb of a charge. Or you can just say per unit charge. That's also okay as well. So instead of saying per coulomb of a charge, per unit charge can still take the place of coulomb of a charge. Right? Okay, then we move on to number 2. So number 2, that is 11,2. Now I'm going to read the statement for you. In the electric circuit given below, the ammeter and the connecting wires have negligible resistance and the battery have no internal resistance. So in other words, the resistance of the wires can be neglected, and then the battery has no internal resistance, with no internal resistance within the battery. So in this case, the examiner has made it clear that it's not there, right? So we only have to worry about external resistance, as you can see from the circuit diagram. So what I'm going to do, I'm going to redraw the circuit diagram, and from there we'll analyze it from there. It won't be difficult because there's only two resistors. That is a resistor of 6 and 80s, that's the battery. And then there are 2 points here that are indicated, which appear black in color. And there is the second resistor of 12. And there we have it. Sorry about that. So here we have another point, and this point here is called a P, and this one here is called a Q. So obviously joins there. And then from there we draw part, and then there's an ammeter. And I think that completes the circuit, right? So obviously I've drawn the same circuit that you have, right? The only thing that is I think I need to remove is this point here. It's at the wrong place. It must be somewhere here. You agree? You should, because you have it. In any case, my preference when you resolve circuits is just to analyze them. And we can analyze the circuit, the circuit without even answering any questions. We only answer questions afterwards. So if you look at this circuit, you will see, yes, there is a battery, There are 2 points, of course. Sorry about that. Again, I need to remove that Q and put it into the correct place. Now it's in the correct place. Now there's 2 resistors connected in parallel, right? Do you agree there's no series resistor here? There isn't. So there's only those 2. There is a battery, you are familiar with that, and then there's an ammeter. So ammeter, of course, we already are familiar with the function of the ammeter, right? Okay, so to me the circuit looks very, very, very simple. So I think we can now approach the questions and see what is being asked. So let's look at the first question. 11.2.1. It says calculate the total resistance of the circuit, right? That's what the question says. Then the question is, we have a parallel combination, right? So that should not be difficult for us to actually calculate that, right? Let's have a look at that. So there are 2 options in terms of this calculation. The first option, we can use the product over sum rule. So by product over sum rule, I mean this. It's product. You don't need to write that, right? I'm just writing that because I am explaining. Otherwise, you don't need to do it. You can just go straight and perhaps label your resistors. So if you call this R1, you can call that R2, right? So you can go and say over R1 plus R2. Then you can further substitute because it is 6 times 12 divided by 6 plus 12. And what answer are you getting here?
4 ohms.
You're getting 4 ohms, right? Let's connect. And then this thing is given 3 marks. So obviously, if you are to mark it 1, substitution, and then answer. Let's break it down. What is the first mark for? The first mark is for the formula, right? What is the second mark for? Substitution into what? Into the formula, right? Okay? And then the last one? The answer. But for you to get that mark, the answer must have the correct unit. Otherwise, you can't just write a number and leave it there. Shall we say that we regard this as option number 1? Shall we go to option 2?
Yes.
Okay. Option 2. Now, option 2 of this will be to use that fraction method, right? So it's 1 over Rp, which is equivalent to 1 over R1 plus 1 over R2. Again, first mark, formula, right? Then we go and substitute. R1 is 6, and then R2 is 12. Second mark for the formula. From here, you must give the answer, right? Then we indicated that if you take the inverse of Rp, right? The inverse of this, it simply means that that one then becomes a negative exponent. So therefore, you can say Rp, in this case, you take the inverse, it's 1 over 6 plus 1 over 12 raised to exponent minus 1, right? Then we should be able to get 4 ohms. Can you confirm?
Yes.
With your calculator? Then we have a total of 3 marks. So just indicate option 1, then option 2. Right, that's the first question, right? Okay. Shall we move on to the second one? So please let's remember again before we move to the second one. This was based on calculation of resistance, right? External resistance, total resistance, right?
Yes.
It was easy because we only had 2 resistors connected in parallel. There was no series resistor. Okay. Now, look at 11.2.2, right? Calculate the amount of charge that flows through the 6 ohm in 40 seconds. If the reading of the ammeter is 0.9 amperes. Now we need to be careful. That ammeter, can you see the connection of it? Is this ammeter connected around R1 and R2? No. So which simply means it is measuring the total current of the circuit. And look at what they want from us. The amount of charge that flows through 6 ohm, right? Can I share the formula with you that we use when we want to calculate the charge? Right? Can I remove some of these things now? Okay. For charge. Right, so let's look at the charge. I want to believe we are familiar with what the charge is. Charge refers to the flow of electrons, right? Okay, but we're not dealing with that, we are calculating the charge. The formula is charge is given by what? Current multiplied by change in time, right?
Yes.
Okay, now having written the formula, right? Let's now go and check our data. If we study and analyze our data, right? From the information given to us, number one, do we have this charge? We do not have it, right? That's what we want to calculate. Number two, do we have current? Do we have current?
Yes.
No, we don't. We do not. Because the question is not about the total resistance of the circuit. The question is specifically on 6 ohm. Where did you get the current of 6 ohm? It's not there. The current that you have there is the total of the circuit. We need to read the questions carefully. 0.9 amperes is measured by this ammeter here. It's not here. This ammeter measures the total current of the circuit. It means this is what it means. It means this ammeter measures current through this one and also current through combined together as a total. They are measured here. So it would not be correct to say that the current for 6 ohm is there. It's not there. It needs to be calculated. It's not there at all. Right, so we'll check and see if we can do that. So therefore, then this is also questionable as well. It's not there. Do we have number 3, the time?
Yes.
Yes, the time is there. What's the time?
40 seconds.
40 seconds, right? Sorted. Now let's now look at it. What was our first question? You see, one thing that I like about electric circuits is that, you see, one solution leads to another solution. We were first asked to calculate the total resistance, right? And that total resistance must now be used. Do we have total current? Yes. Do we have total resistance?
Yes.
Yes. What do we need now? We need current through 6 ohm, right? Now, what do you think? The steps must be that we must take? We go back to the question. We check: is there any other data that can assist us in this? Do you see anything that can assist us? What is it that we need in order to calculate this? Let's go back to the properties, right, of parallel resistors. What is that one property that is important about the parallel resistors? They divide the electric current, right? But they share the same. That's all that we need. That's all that we need, right? Because once we have that voltage, we can now calculate what? Individual current. So we can calculate the current through 6 ohm. Then we can also calculate the current through 12 ohm. But the interest of the question is on 6 ohm, right? I'm going to use that space on the other side. So let's do that. Resistance? The answer is a yes, right? Do we have total current? Yes. So what's the formula then? The formula is voltage equals to what? Current multiplied by resistance, right? Now, what is the current? 0.9, right? What is the total resistance? It's 4 ohms, right? What is the answer here?
3.6.
Sorry?
3.6 volts.
We're getting what?
3.6 volts.
3.6?
Volts.
3.6 volts, right?
Yes.
Okay. So that is the potential difference that we have, right? Now, can we now go and calculate the current through 6 ohm? The answer is yes. Current through 6 ohm is given by what? The voltage, right? Because the voltage is the same. So it's voltage divided by R 6 ohm, right? If you prefer to write it that way, you can just say R. Then it's 3,6 volts divided by what? By 6 ohm, right? What is the answer here?
0.6.
Sorry?
0.6.
The answer is 0,6, right? Amperes, right? Now, before we go and conclude and do the calculation, right? Because we are learning and then we calculate and all of that, I want us to look at also the current of 12 ohms. There's something that I want us to check, right? Remember, current through 6 ohm and current through 12 ohm, when added together, it must give us the total of the circuit. So I want us to confirm that first, before we conclude on our question. Then we'll calculate just now. We have what we need, right? But let's check 12 as well. Shall we go there? Current through 12 ohm, right, is also given by voltage divided by R 12 ohm. You don't need to write it like that. You can just use R. What is this? It's 3,6 again, right? Divided by 12 ohm. Give me the answer, please.
0.3.
The answer is 0,3, right? Will I be crazy if I assume that 0,3 plus 0,6 must give me 0,9? Does the calculator confirm that? Or something is wrong with my head?
No, it's correct. It's correct.
It is correct, right?
Yes.
Thank you. Now we've confirmed that the path we've taken in terms of solving this is the correct one, because the total current of these two added together is giving us 0,9. But the interest of the question is on resistor of 6 ohm, right? Do we have the current there now? Yes. Shall we now calculate? Right? That is why, is it 5 marks?
Yes.
That is why it's 5 marks. Right. And a lot of people would have used 0,9. And the 0,9 is not correct. Actually, you must check in your circuit. Check where your ammeter is. If the ammeter is meant to give a reading of the parallel section, right, it has to be connected there, right next to that resistor. If you see an ammeter there, then you must know that that ammeter is reading a current through 6 ohm. If you see one somewhere there, right, you must also know it's reading also in R2, right, which is 12 ohm. Yeah. But once you see it there, you must know it's measuring the total of the circuit. So that is very, very important before you solve your circuit diagrams. Shall we now substitute? 0,6, right? Multiplied by what? 40, right? What is the answer? 24 what? 24C, right? Capital letter C. Or you can write the full weight coulombs. I'm sure a charge is measured in coulombs, right? So that's basically how the question is done.